Python sets are a mutable but unordered data type. So let's talk about it and learn everything you need to know about Python sets. Welcome, I'm Cons, I got a master's degree in computer science and currently work as a graduate research assistant, and I'm here to help you to learn computer science with Python. We already talked about Python lists and tuples, for which you can find the videos up here. Both of those are ordered data types. That means every element has an unique index with which we can access it. However, Python sets are strongly influenced by mathematical sets, and those don't have an order and also don't allow duplicates. But enough talking, let's declare our first Python set. Declaring a Python set works in the same way as we would declare a list or a tuple, however we don't use brackets or parentheses, this time we're going to use braces. So we enter our list name S, and then our first brace, and then our first element, which can be of any primitive or even complex data type. So here we have first a string, then we have a bool, and now a float, and lastly a integer. When we press enter, we can see that declares our Python set. Because Python sets don't have an order, we cannot access individual elements with an index. However, we can check if an element is contained in a set with the in operator. So if we want to know if our A is contained in S, we're going to use the in operator. So we state first A, then in, and then we state the name of our set, and that returns a boolean telling us if our element is contained in the set. If we check if an element that is not in the set is in the set, we will get false. And as Python sets are mutable, we can also add new elements to a set. So if we want to add something to our set S, we just use the function add and then enter the element we would like to add our set, and then we have a look again and we can see now our set contains 0.23, 42 true, A and B is the element we just added. We can not only add single elements to our set, we can add multiple elements coming from a list, tuple or another set. Here we have our set A, B, C, D, and we have a list D, E, F, and now we can use S update and add L to it. And when we have a look at S, it now contains the additional elements E and F. But there wasn't added a second D because a set cannot contain duplicates. So when we use the update function or the add function, the set will actually check if the element is already contained in our set and then doesn't add it if that is the case. We can also use the update function with a tuple. So here we have the tuple F, G and H, and we use update T, and this added our tuple to our set. Now we have the additional elements G and H. And last but not least, we can also use another set to use the update function. So we call S update and use our set M, which contains H, I and J, and we enter update M, and when we have a look at S, it now contains the additional elements I and J. So keep in mind when you add new elements to a set that sets don't allow duplicates, and therefore if you add something to a set that is already contained in it, you won't find it in there a second time. I actually prepared several Python cheat sheets for you. You can pick up for free as a high resolution PNG in my Gumroad shop. And if you want to print out those cheat sheets, you can even find a printable PDF version for a small amount of money in my Gumroad shop or as a tier 1 or higher Patreon subscriber. So check out the links down below in the description to pick up your free Python cheat sheet. So add and remove are functions that allow you to remove a specific element from a set. But there's two more functions we could use to remove elements from our set. And the first one is pop. So first we have a set declared up here, and then we use pop. And pop doesn't take any arguments, it will remove an arbitrary element from our set. So here we used pop, and it returns actually the element we have removed. And when we have a look at S, A is now missing. And the last functions to remove elements from a set is clear. So we enter clear, and that will result in removing every element from our set and will then lead to an empty set that is declared with the set and two parentheses where there's nothing in there. Now that we have seen the set with the empty parentheses, this is actually a function to turn lists and tuples into a set. So here I have a list and a tuple, and if I use the set function and enter a list between the parentheses, that will result in a set that contains all the elements stored in the list. And we can see that the duplicate we have here in this list, the B, is not present in our set, as sets don't allow duplicates. And we can do the same with the tuple T. And here we have the duplicate F, and this is also not present in our set when we turn a tuple or a list into a set. Sets also support the min and max functions to get the maximum and minimum element of a set. So here we have the set A, AA, B, and C, and if we enter max S, we get the maximum element by the lexicographical order, and this is C. But we could also change the sorting key for the max function, so we enter max S key, and this time we would like to have the element with the maximum length. So we enter len as our key, and then we get the element that has the maximum length, which is of course the element AA, because it has 2 characters. And we can enter min s, and this will return the smallest element according to the lexicographical order. If you like this video so far, make sure to give it a like so it can spread to more people and more people can start to learn about Python sets. The mathematical set theory provides different operators that allow you to combine sets to form new sets. And the first one we are going to look at here is the union. When you unite 2 sets, the new set will contain all the elements that are contained in both sets. And in Python, we have the union operator for that. So here we have 3 sets, S, M, and N. And if we enter S union M, this will create a union out of S and M. So the resulting set that is given back as a return value contains A, B, and C, because all those elements were contained in S and M. And the union function also allows us to unite more than 2 sets. So we can enter S union M and comma N, and this will create the union with S, M, and N. The update function we have seen earlier is actually a union, where the union result is stored in the set the update function was called on. So if we enter S update M, we can see this will result in the union of S and M, and then the union result will be stored in S. In Python, you don't even have to call the union function to unite sets. You can also use the pipe operator. So we start off with the same sets we have before, S, M, and N, and then we use the pipe and enter S, M, and N, and this will also result in the union of those 3 sets. The inverse operation of the union is the set intersection. An intersection of 2 sets only includes elements that are present in both sets. So here we have our sets S, M, and N, and to create the intersection between S and M, we enter S intersection M, and then we can see it only contains B and C, because B and C are present in S and M. And we can also use the intersection with more than two sets, so we can enter N as well. And this will result in C, because only C is contained in all 3 sets. If we got another set K that only contains the element Z, and then we create the intersection of S, N, M, and K, we can see this will result in an empty set, because Z is only contained in K, but not in the other sets. And the intersection states that every element in the intersection has to be contained in every other set that takes part in the intersection. We can also update a set with its intersection with another set by using the intersection update function. So as intersection underscore update, and we enter M, and we can see it doesn't return a value, but when we have a look at S, it now contains the intersection between M and S. The next set operation is the difference, and the difference of 2 sets only contains elements that are exclusively present in the set the difference was called on. So here we have S and M, and if we enter S difference M, we will get the set C, because C is the only element that is exclusively present in S. And the difference also comes with its own update function, so if we enter S difference update M, we won't get a return value, but if we have a look at S, S now contains the difference of S and M. Closely related to the difference of 2 sets is the symmetric difference. The symmetric difference is the union of 2 differences where the sets are switched. So if we have a look at S and M, and we create S difference of M, we get A. And if we switch it around, M difference S, we get E. And the symmetric difference is the union of those two sets. So if we enter S, symmetric underscore difference, M, we get the set that contains A and E because it's the union of the two differences. And the symmetric difference also comes with its update variance. So we enter an underscore update after it, we won't get a return value. However, the symmetric difference of S and M is now stored in S. When working with sets, it's often important to know if they are disjoint. Disjoint means that they don't have any elements in common. So if we have a look at the code here, we have the set S containing A, B, and C, and we have the set M, D, E, and F. So those two sets are disjoint. And to check if two sets are disjoint, Python offers the function isDisjoint. So we enter S and then call isDisjoint M, and this will result in true because they don't have any elements in common. We can also switch out M and S here, and this will still result in the same value because they are still disjoint. And if we enter another set N containing the elements B, X, and Z, and then call S isDisjoint N, we can see it is false because S and N share the value B. The last two important properties of sets are the subset and superset property. A set is a subset of another set if it only contains the values that are also present in the other set it gets compared against. And reverse, a superset is a set that contains all the values that are present in the set it gets compared against. So if we have a look at this code, we have the sets S, M, and N. And if we would like to check if S is a superset of N, we enter S is superset N, and that will result in true because S contains all the values that are contained in N, so A and B. If we check if N is a subset of S, this will also result in true because N only contains values that are present in S. If we check if N is a superset of S, that will result in false because it's missing the value C. If we have these sets S and M here, we can see they both contain the same values. And if we check if M is a superset of S, that is true, but we can also check if M is a subset of S, and that is also true. And this is interesting because when two sets are the same, they're actually the sub and the superset to each other. We can also check the length of a set with the built-in len function. So we enter len s, and we can see that returns the amount of elements that are stored in our set. So we have s, a, b, c, and that will result in true if we call the len function. Last but not least, let's talk about the copy function. As sets are a mutable data type, they support the copy operation. So if we have a look at our code here, we have the set a, b, c, and now we take m and assign s to it. And then we take n and assign a copy of s to it. If we have a look at m, it contains the exact same values as s does, and the same is true for n. However, if we remove an arbitrary value from s, we call pop, and we can see s doesn't contain a now. And then we enter m, and we can see m also misses a, because m and s actually point to the same set, or they have the same reference of that set. If we enter n, we can see n still contains a, because here the set was copied with all its elements and a new reference to a new set was created. If you want to learn more about copies, references, and pass-by assignment of Python, check out this video up here. I hope this video was helpful for you. If you got any questions on Python sets, let me know down below in the comments. Don't forget to pick up your free Python cheat sheets in my Gunmode shop or on my Patreon, with a big shout out to my Patreon subscribers. Make sure to subscribe and hit the bell icon so you get notified when I release a new video on Python, programming, and computer science. Check out this video over here about Python dictionaries, and I wish you a fantastic day and hope to see you soon. Bye bye!